Okay. Hello. Recording live from somewhere. We're going to talk about the do now that we had the other day. This reads oxaliplatin, which has a molecular formula of C8H14N2O4PT, is a platinum-based anti-cancer drug that binds the nuclear DNA of cancer cells to induce cell death. If you're interested in any sort of oncology or any sort of medicine, this is one of the most fascinating aspects of medicine to me. I love metal-based anti-cancer drugs. I think they're so cool. They're used in about 50% of chemotherapeutics. Most people get cisplatin, which looks something like this. It's a very cool drug. It has platinum center with 2 chlorido groups and 2 ammonia groups. When it's in the cell, it undergoes something called a double equation reaction, where both chlorido groups pop off and are replaced with waters. This then gets into the cancer cell, and it will find in your DNA 2 guanines that are pretty close together. They will lose their 2 water molecules, and they will form a double linkage with DNA. Boom, boom. Now, what's interesting about this is that it kinks the DNA so much that it activates a pathway in your cell called the apoptotic pathway. That is also known as the suicide pathway in your cells. So what this does, gets in your cells, binds DNA, guanine, and then it triggers cell death mechanisms. It's very cool. There are some issues with efficacy, which is where oxaliplatin came in the 1980s and was approved for FDA usage in around the mid-2000s. So, with this, let's try to examine what the molecular weight of oxaliplatin is. And this is going to be important if you want to be a doctor, because at some point you'll have to prescribe these if you are an oncologist. What is the molecular weight of oxaliplatin? First off, how do we find the molecular weight of something? Good question. We have a periodic table of elements. Let's take a look at that periodic table of elements. Boom, okay. Zoom in, zoom in, zoom in, zoom in. Under each element, we have a molecular weight. This right here is my favorite metal. It's called rhenium. You might not be able to read this very well, but it says that the molecular weight of rhenium is 186.207 grams per mole. So if we want an answer of what our compound is in grams per mole, you would just have to add up the constituent parts of its molecular formula and then add them together. Easy peasy, lemon squeezy. So we see here C8H14, N2O4, PT. These are the constituent components of this molecule. How much do each of these weigh? What are each of the molecular masses of these? And for the record, I'm going to be using the largest whole numbers, the roundest whole numbers of these molecular weights. So if you see that I'm using 12 grams per mole instead of 12.01 grams per mole for the molecular weight of carbon, I'm doing it just to go quickly. 8 times 12 grams per mole. Why do we do this? There are 8 carbon atoms, each of which weigh 12 grams per mole. Let's do the rest. Plus 14 times 1.00 grams per mole. This is for hydrogen. Plus 2 times nitrogen. Could remember what N stood for. 14 grams per mole. 4 oxygens, which are 16 grams per mole. In platinum, one of them, 195 grams per mole. Easy peasy. I'm going to do this mental math in my head and just put it out here. 8 times 12 is 96 grams per mole. This is 14 grams per mole. This is 28 grams per mole. 64 grams per mole. 195 grams per mole. I'll give you a second, pause this video, add all of these up. This equals 397 grams per mole. That is our molecular weight. In truth, the molecular weight is 397.3 grams per mole. So even just rounding up, like, did pretty well there. So let's say now that you're a doctor and you want to prescribe 85 milligrams of oxaliplatin to your patient. You don't want to overshoot this. You don't want to undershoot this. If you overshoot the amount of oxaliplatin, you could just start killing cells indiscriminately. If you want to specifically target cancer cells, good. That's what you want to do. That's how you cure cancer. But if you use something that's really, really powerful that is able to kill cells, then there are probably going to be some off-target effects. So if you put too much in there, you might kill the cancer, but then you might kill their kidneys, or you might kill their hearing, both of which are horrible, terrible side effects of platinum-based anti-cancer treatment. You also don't want to give them too little oxaliplatin. That's going to suck. They're not going to feel the therapeutic benefit of that. A lot of these prescriptions are based on body weights. They are based on numbers of moles according to the volume of the cancer in question. It's really important that we get this right. So a patient is prescribed 85 milligrams of oxaliplatin. How many millimoles of oxaliplatin does that represent? So we're going to use something called dimensional analysis. And this is something that we should have covered in our summer homework and brought to class. It is absolutely foundational to the rest of chemistry to internalize dimensional analysis. So we see that we want to go from milligrams to millimoles. So like, how are we going to get there? So we're currently in milligrams. But we see here that we have something in units of grams per mole. This is more or less just a ratio. We can go from moles, then to millimoles. That should be really easy. But we're currently at milligrams, and so far nothing that we have been given is in milligrams. So we need to convert from milligrams to grams in order to use the molecular weight to go from grams to moles, and then from moles to millimoles. 100 milligrams, milli is equivalent to 10 to the minus 3 grams. 1 gram equals 10 to the positive 3 milligrams. 10 times 10 times 10 is 1,000. 100 milligrams is equal to 1 gram. Boom, already at it. We see here that for every mole of oxaliplatin, it will have a mass of 397 grams. 397 grams per mole. And then we're currently in moles. Let's just convert over to millimoles. 1 mole equals 1,000 millimoles. Now, before we find the answer, let's cancel out all of the units. Milligrams, now we're in grams. Grams, now we're in moles. Moles, now we're in millimoles. Something else that I find very helpful, you see here and here. In the numerator, there is a 1,000. In the denominator, there is a 1,000. Easily cancel those out. So what we're left with is 85 over 397 millimoles, which is equivalent to 0.21 millimoles of oxaliplatin.